see if we live. I don't think so. To ensure. So we are live. I thought I'm live much later than I previously thought. And my camera is almost live. I'm now on Linux, so OBS is a bit funny, but it's working okay. Let me just, how do I get the link from so I see my chat in OBS. Just checking the chat. It seemed to work, but I don't have anything else. Just trying to check how much GPU is being utilized. Not even sure OBS is using any GPU. It says CPU 12%. Have to look at it in more details later. Let me just publish the. Yeah, this thing should have opened in another tab. Have to fix it. Do it later. I'm just trying to share the stream just in case someone wants to join in and have a chat. You're more than welcome to. There's a mouse brain. Oh, this really plays with your head. Anything on Twitter? Anyway, I don't really use Twitter, just sell drugs on it. Don't use them myself. Never use your own produce. The first rule of better not say before I get cancelled on YouTube. We have that link, I'm pretty sure would not work. Have to actually do it in do it over here. Join me live. Join in for a live chat. I'll post that and get out of there. We don't really need that window. Just check my cell again. Yeah, someone on LinkedIn posted swearing by this Falcon 40 billion what's called neurons chat, but it kinda apparently it's in developed in Abu Dhabi somewhere, but the Hugging Face version of it, just, is it me or that screen is empty? It doesn't actually produce anything. Yeah. Not sure what's up with that. It's calculating something. It just seems like the chat window is empty. But then we go on the main page. You have this open LLM leaderboard pinned. Let's see what other LLMs are available. So say take the first one there. I don't know what it is. I don't know what the parameters are. And I already tried it before. and within 4 or 5 prompts I reached the limit, and it's asking me to log in. I'm not sure if it's free or not, and I don't know if not sure why I can't log in with Google or something. Because I'm not on Chrome. Anyway, I can try it another time. Let's use the standard ChatGPT and Bard. Maybe Bing is giving me attitude a lot of the times. So we have this Flask application. It's on. You can access it from the main page. Over here, we will be redoing all those applications in Flask Python. This one is the first that is running. It should actually load something on the get-go, but try and quickly change it now. See how long does that take, and it's generating these different types of noise. You can choose between uniform, Gaussian, periodic, inverse frequency. Noise is of most interest to us. I don't know why it takes so long. I think it's because there's just too many parameters, too many. It's like too many data points in there. Yeah, number of sample, we're doing 1,000 samples. Yeah, I had pretty much most of the day yesterday I spent on not developing this. To develop this, it took I don't know, an hour or two in ChatGPT and sometimes Bard. So that was pretty straightforward. Don't remember which one's which, but then the rest, so 90% of the time spent on these settings that just didn't work to begin with. We had to allow cores. Your app it seemed to work okay now, but obviously there's some more improvements needed. And currently I'm running this in a regular terminal. Also need well, because I need root access. That's because where is it actually deployed? Yeah, because I need for it to actually appear on the website, it needs to be secure, and what makes it secure is this certificates from Let's Encrypt, and those directories are currently, well, should be, I don't want to change it, they only accessible by the root user of the server. So that's what I spent most of the day yesterday trying to sort out. So let's continue from where we left off. We also probably do, yeah, this signal generator. Oh, I don't know what's up with that. That really took a long time to run. We want to keep those URLs because I might have somebody might be using them, these URLs, because I published them linked in various places. You might want to keep the same URL. Currently in this folder we only have this HTML that it is displaying that, and the reason this doesn't work is because we don't have the API server running. So that's what we are using Flask for, and we actually already have an EEG. No, wait. EEG simulator. Sorry, so we're already. No, wait. EEG generator. We have this Python script. Just open this in the folder just so I can see what file was modified last, and it will be this one. This was modified Friday. Yeah, unfortunately we'll have to, for something like this, because it will quickly get more complicated, we'll have to have a backend. So as opposed to some other tools that don't have a backend at the moment, like this ECG game, it's all happening in the browser. This EEG generator will have to have a backend. We'll be using Flask for that. Yeah, so this would not work anymore because I don't have the LabVIEW APIs going. There's only videos remaining. So I can either use this description, essentially pop it into, yeah, so that will be keep giving you errors. It's all the JavaScript from LabVIEW that doesn't work anymore, mainly because it can only run on Windows, and I'm on Linux. Don't wanna use Windows anymore. So let's start by popping this description into the chat.
Synthetic EEG signal generator. This tool is used to create artificial EEG signals. It's particularly useful for testing and evaluating algorithms, devices, or theories related to electroencephalograms. Window size. This parameter determines the duration of time over which the EEG signal is sampled. Larger window sizes provide more data points, improving signal accuracy but increasing computational requirements. Smaller window sizes
Yeah, that's okay. That's pretty much paraphrasing our description. We want to, pretty sure if I hit that button, Edge browser will collapse just because it doesn't like using microphone. Can do speech. This extension working well. Yeah, I'm not sure what's up with this very low numbers. Yeah, nobody is using Edge, or I don't know if these numbers are just for Edge on Linux. Yeah, we kind of have to use. I would use Bard or ChatGPT on. So this is generally what we did yesterday: installing Flask, generating an app, hosting it, posting it, deploying it. Yeah, restarting the Apache server like 100 times because things didn't work. Now it's working okay. It's over here. I actually want to use this I don't know why it's taking so long for it to run. We actually want to use this inverse F as a baseline EEG. So we essentially okay, so I had the Flask instructions. Let's just start a prompt file in here. We already have prompts, text, prompts, O2, txt. Let's see what, right, so we have that thing from, it would be from over here, would it? Is this description full? Ah, yes, because it didn't truncate the text. So we want to generate prompts out of this. Sorry, we also need the. We need that one. Hi, Rohan. How are you? So there might be a bit of a delay. Should be a couple, about 10 seconds, 20 seconds. Yeah, there's about 20-second, 30-second delay. What are we doing? So we're doing multiple things. Yesterday we managed to deploy a Flask application. It's available. You can go check it out on barneychaos.com. It's this inverse F noise function. I'll pop it in the chat. Should be available in the chat. It should actually load signal to begin with. So you can select here between different examples of noise, uniform, Gaussian, periodic. That one would be Gaussian. Periodic will have some sort of sinusoid in it. We had a similar tool like this running before, but because we moved for technical reasons, it's not running anymore. So we redoing everything in Flask and Python. So this inverse F type of noise is of particular interest. That's what its frequency domain looks like. This is logarithmic. We're particularly interested in this one because it looks a lot like a baseline EEG, brainwave activity. So now we want to use it in this tool that's doing a synthetic EEG signal generator. You can see previous videos of how it used to work over here. So here we got, this was a while back. So essentially you can view a video in a video. Why the quality is so low? Normal. It's meant to be HD. It's definitely not HD on my screen. Ah, now it is. Okay, so it's essentially pause this for a sec. No, I don't want to see that. YouTube is annoying. So you could select your power for each frequency band, EEG frequency band. Oh, come on. It's called the resolution of this thing. I don't know why does it do that. Is it my computer struggling? It shouldn't be the case. Yeah, I used to record, and essentially this would be what, 2K, not 4K. 4K will be double. And now I only do the live streams, unfortunately, in only 1080p, but then I record in higher resolution as well. So eventually, there should be higher res videos coming out of the streams. Anyway, back to this. I just close the window to make it smaller, so you can adjust a bandwidth, power for each frequency band, and it will generate the signal, synthetic signal for you. Let's see. Close that one. You can close. There's a problem with the server. But still, yeah, I'm still live. Anyway, so we be using all this stuff that we had prior. Write Python script with Flask page deploy on existing server. Let's pop it into pod as well quickly. It's fine. Bot generates everything. Maybe there's a human checking what it generated and then it's spitting it out, whereas ChatGPT is actually generating as it goes. We can tell it's more a natural kind of real-time generation.
Sure, I can help you with that. Here are the steps involved in designing a Python tool that displays synthetic EEG and its spectrum, with controllers for changing the amplitude in each frequency band. 1. Import the necessary Python libraries, such as NumPy, SciPy, Matplotlib, and Flask. 2. Define the functions for generating the synthetic EEG signal and its spectrum. 3. Create a user interface with controls for changing the amplitude in each frequency band. 4. Update the plots of the synthetic EEG signal and its spectrum when the controls are changed. 5. Deploy the Python script as a Flask application on an existing website. Here is an example of the code for generating the synthetic EEG signal. Here is an
Okay, we actually want those as steps. Oops, that's wrong. Okay, it didn't actually. So yes, we're happy with NumPy, SciPy, Matplotlib, and Flask. and spectrum. Frequency band. Create a user interface, changing the amplitude. We want to be able to, yeah, this is a common thing. We don't want a frequency band. We actually want instead of a frequency band, can you have a mean frequency and bandwidth? And we want to be able to control the bandwidth. So the mean frequencies should be having a frequency of 10 and a bandwidth of 2, so it will be essentially from 8 to 12. Is that a standard thing? I think so. That's a good description. Right, so essentially creating all the prompts for generating our code. And Bud, yeah, Bud is not the best at it. Well, I don't know, maybe I got used to how ChatGPT does things. So do we mention Flask? Yes. Would we like to change window size? Well, probably yes. Window size. Right, so this one is not clear. Need to pop it at the define function generating synthetic EEG. We'll organize it later. Data process detection at the spectrum when controls a change. This will be a separate. So mention Flask a couple times, but that's okay. I want to stick to Flask. Yes, we want to add controls. Frequency band. So let's start this again, see what it says. And we had some example code as
Create
well.
a full Python application with a Flask web interface and interactive controls for generating synthetic EEG signals and their spectra can be a complex task. Below is a simplified example of how you can start building such an application. You'll need to expand and refine it to meet your specific requirements. Next, you can create your Python Flask application. Now, create a folder named Templates in your project directory, and within it, create an HTML file named index.html for rendering the web page.
We already have. Let me close all this fast because we have this stuff from prior. Right, this index obviously can go. We don't need this anymore. This is not a production folder. This is a prototype. That would be the Flask application. So normally would be called the app. I don't know how to deal with multiple applications. The fact that they will be all called the same name. We'll deal with that when deploying. So that's good. We have the, why they're all, this amplitude. Where's the frequency? The frequency, yeah, bandwidth, the frequency should be hardwired. So I understand why it's not here. Yeah, it's just over there. 1, 4, 8, 12, and 30. That will be the median frequency, and those will be the default bandwidth. So we'll test it later. It's currently doing this chirp, which is cosine, sinusoid, cosinusoid, whatever you call it. I'm not a mathematician, so I can call it whatever I want. Even mathematicians call things whatever they want. They just come up with stuff. So I'm good to go as well. SciPy. Pretty sure we have all those installed. I'm not using virtual things. My website is actually a virtual. It's called whatever it's called, virtual something. Can make yet the window in is a bit funny. It doesn't expand, which I don't particularly like. But we can deal with that. Know why the window size, amplitude, bandwidth are global variables. Okay. I don't know Python, so bandwidth request from load. Right, so this is interesting. This is a post method. The problem with the current application, yeah, so whatever we make should be better than what we currently have, so that's a no-brainer. But I'm just looking at this Flask application that we were making yesterday, and it's way too slow. It's like ridiculously slow. You can actually see here how network, how things are getting loaded. Yeah, that's how long it takes. And it's downloading whatever this 7.4 megabytes for plotting this. It's like ridiculous. Yeah, we'll have to fix that. There's obviously something wrong. Yeah, inverse F12, 13, 14, so double, another 7 megabyte loaded. So that's not cool. Okay, we pop this. Yeah, the script is in the HTML. It's okay if it stays short, but if HTML goes, there are errors. Why there are errors? Because it's incomplete. That's why it asked me to keep generating. Yeah, now it's complete. So we have the app. Okay, what's that? We had the Python and the HTML code. Still got body HTML is still an error. What's that? JSON to JSON. To JSON. Sweet. Script. Yeah, that's what it generated. Just pop it in the chat. Right, it's correcting something. It's retrieving data from Python variables. This is the same. JavaScript, Python using the Jinja template. Okay, but that's check the app. Debug true. Folder yes. This code setups like Flask web application that allows adjust window size should benefit when it's in the form. The EEG signal spectrum will update according to run application. It's meant to be in templates file. Don't know why it always needs yeah, this so Flask always assumes that you have a folder name. Oops, no, not that. Folder name templates, and the index file should be init move yes. Should be calling. How's the HTML calling the app variable? Wait. What the Python file should be called?
To complete the Python code, you'll need to add the remaining part of the Flask application that was truncated in the previous responses. Here's a complete Python file that you can use for your Flask application.
What was wrong with that one? Yeah, JSON.
This code includes the complete Python Flask application that generates synthetic EEG signals and displays their spectra in response to user input through a web interface. Make sure to save the HTML template as template/index.html in the same directory as the Python file. You can run this Python script, and it will start the Flask web application at http://localhost port 5000.
That's the default port. We'll have to change that later. Does it matter what the Python file called?
The name of the Python file doesn't fundamentally matter as long as you execute it correctly. However, for clarity and convention, it's a good practice to choose a descriptive and meaningful name for your Python file, especially if your project grows in complexity.
Okay, AppPy it is. I didn't actually. Is it now using? It's not using JSON file. It's weird. It keeps recording everything I say. That's okay. Because I also know if it didn't translate to text properly, that's because I didn't say it properly. So I have to speak clearer. But what I'm looking for is how is this app file different? First of all, this JSON file is not being used. Is not being used.
If you are not using JSONify in your Flask application, it means you are not explicitly converting Python objects to JSON format for responses. In the provided example, JSONify was used to convert Python dictionaries into JSON format before returning them as responses to client requests. If you are not sending JSON responses and are using HTML templates to render your web pages, you may not need to use JSONify. In this case, you can focus on rendering HTML templates using the render_template function, which is what the example code demonstrated. Here's a quick recap. Use render_template to render HTML templates when you want to display web pages. Use JSONify when you want to send JSON data as a response, which is commonly done in RESTful API endpoints. The choice between render_template and JSONify depends on whether you are building a traditional web application with HTML templates or a RESTful API that primarily
being
used
in the code.
I apologize for the confusion in my previous responses. You are correct, there is no usage of JSONify in the provided code. The code primarily uses render_template to render HTML templates and does not send JSON responses. Here's the relevant part of the code. It renders the HTML template and passes Python variables to the template for rendering the web page. Thank you for catching that, and I apologize for any confusion.
Okay, now I don't get it. So can I remove JSON file?
Yes, you can remove any mention or usage of JSONify from your code if you are not using it to send JSON responses.
Yeah, that's what it is.
In the provided code example, JSONify was not used, and it's not needed for the functionality of generating synthetic EEG signals and displaying their spectra in the HTML template. You can safely remove any references to JSONify from the code. It won't affect the core functionality of your Flask application as long as you are only rendering HTML templates and not sending JSON responses.
Can you regenerate the code? Because I'm also having an error in the index HTML on line 52. Let's see if it actually gets online or online.
I see that you're encountering an issue with the HTML template. I'll provide you with a complete set of corrected Python code and an HTML template. Make sure to create a templates folder in your project directory and save the HTML file as index.html inside that folder. Then, run the Python script. Here's the updated Python code. Here's the corrected HTML template, index.html.
Yeah, the script, but still the same. Continue generating. I don't know what's up with that. There's some sort of weird
This
script
corrected
thing.
HTML template includes all the necessary elements and should resolve the issue you encountered on line 52. Please ensure that you have created the templates folder and saved the index.html file in that folder before running the Python script.
Okay, I'll just go with this. 85 lines, 85 lines. Still a problem in the same spot. Python is now not using JSON file. It was 87 lines. Still 87 lines. So it should be fine. Still have can we open with live server? Right, it's actually working. Oh, do I really? Okay, few things. So surprisingly, the code is working even though the interpreter Visual Studio Code is giving me an error. I'm using Visual Studio Code just in case it's important. Now, can all the values be populated with default and chart being displayed the first time I open the HTML? See if it understands.
If you want to ensure that all values are populated with their default values and the chart is displayed when you first open the HTML page, you can modify the code to initialize the default values in the HTML form. Here's how you can do it. Modify the input fields in your index.html file to include the value attribute with the default values. With this modification, the input fields in the form will be initially populated with the default values defined in your Python code, default_window_size, default_amplitude, and default_bandwidth. When you first open the HTML page, these default values will be displayed in the form fields, and the corresponding chart will be generated based on these default values. This change ensures that the initial state of the HTML form reflects the default values, and users can modify them as needed.
And where is this in the code in the header, or sorry, this is how much I know about is the script thing? No, input. Sorry, where about does this line goes in the code?
My apologies for any confusion. The modification I mentioned should be made directly in the HTML form fields in the index.html file. You don't need to make changes to the Python code itself. Here's the part of the HTML code that needs to be modified within the less than form greater than element. You should include the value attribute with the window_size, default_window_size, expression inside each input field that you want to initialize with default values. This modification should be done directly in your index.html file within the less than form greater than element, not in the Python code. This change ensures that when you first open the HTML page, the default values are displayed in the form fields.
Right, so it goes in the beginning of the form. What? How did it get that? Am I speaking that unclearly? Gives lines to other. So this will only populate some of the input. Would it? Type window size. It didn't populate the window size. Wait, what is it doing now? Why is it loading for a 37, 32? What? Syntax error. Yeah, I told you it has trouble with
I apologize for the error. The window underscore size, default underscore window underscore size, syntax is Jinja2 template syntax, and it should be used within a Flask template context, not directly in a standalone HTML file. If you're encountering a syntax error in your HTML file, you should use a JavaScript-based approach to set the default values in your input fields when the page loads. Here's how you can do it. Remove the window underscore size, default underscore window underscore size from your HTML file. Add an id attribute to each input field in your HTML, for example. Use JavaScript to set the default values when the page loads. Place this JavaScript code inside a less than script greater than tag at the bottom of your HTML file, just before the closing less than body greater than tag. This JavaScript code will set the default values for your input fields when the page loads.
Okay, first of all, obviously label that's already appears once. We need an ID number for that. Why is it just not doing it for me? Okay, we'll try this one. So it has an ID of window size, and then we'll modify this in the JavaScript. Yeah, I'll probably have to ask it to separate the JavaScript into another code. JavaScript. Don't know which part did it go to, and why is it not parsed correctly? Not parsed, whatever it's called. Its function. Don't get how that works. Can you rewrite the HTML code with all the necessary changes?
Certainly, here's the revised HTML code that includes JavaScript to set default values for your input fields when the page loads.
Oh, come on.
Each input field now has a unique id attribute. JavaScript is used to set the default values for each input field when the page loads. Ensure that you've included this updated HTML code in your index.html file, and it should set the default values for your input fields correctly when the page is loaded.
Can you generate the whole HTML code without any missing bits or placeholders?
Certainly, here's a complete HTML code for your index.html file with default values set using JavaScript.
Right, so we have amplitude, window size, amplitude delta, bandwidth delta, amplitude theta, bandwidth theta, so on and so forth. We have an ID for each one. So in the script, we will have the default value.
This code sets default values for all input fields using JavaScript when the page loads. You can copy and paste this code into your index.html file, and it should work as expected.
And now the error also went away. We had error on line 56. It's not there anymore. That's great. Right, now we have the values. And this page is not update EEG. It's not doing much. Hopefully my microphone is still okay, because yeah, getting this error message for... Is my microphone? Right, no, it's just that was quiet. So that's there. I can delete this. Is the Flask, how do I run the Flask application?
To run a Flask application, follow these steps. Ensure you have Python installed on your system. If not, download and install Python from the official website, https://www.python.org/download/.
Okay, we should have known this from yesterday. We actually have to run this. Okay. Getting get a 404 once. This index from the... No, that's not working. So the application is there. It should be displaying the EEG signal and spectrum. These bits ideally would be sliders. Do we have it in development? No. So if you make any changes, they will not take effect, I think. I don't see any charts being displayed in the Flask application for EEG or frequency.
If you're not seeing the EEG signal and frequency spectrum charts displayed in your Flask application, it could be due to several reasons. Here are some troubleshooting steps to help you diagnose and resolve the issue. Check for errors. First, make sure that you don't see any error messages in your terminal where the Flask application is running. Any errors in your Python code or the HTML, JavaScript code can prevent the charts from being displayed. Verify JavaScript in Plotly. Ensure that you have included the Plotly JavaScript library correctly in your HTML file. You should see this line in your HTML file's less than head greater than section. Make sure there are no typos or issues with the inclusion of this script. Inspect Browser Console. Open your browser's developer tools and check the Browser Console for any JavaScript errors. It may provide clues about what's going wrong with the JavaScript code. Check for plotly code errors. Review the JavaScript code that initializes and plots the EEG signal and frequency spectrum charts. Make sure the code correctly references the HTML elements where the charts should be displayed, in your case, the less than div greater than elements with IDs, EEG_signal, and EEG_spectrum. Ensure data is passed. Verify that the Python code is correctly passing data, t, EEG_signal, frequency, EEG_spectrum, to the HTML template. Check that the data is correctly formatted and populated with values. View page source. Right-click on your web page and select View page source in your browser. This will display the HTML source code as it's rendered by the browser. Check if the plotly chart initialization code is present in the HTML source. Clear browser cache. Sometimes cache versions of web pages can cause issues. Try clearing your browser's cache and refreshing the page to see if the charts appear.
It means that the charts are not in the HTML or are too small size.
If the charts are not appearing in the HTML or are too small, it's likely a problem with how Plotly is configured or with the HTML layout. Here are steps to diagnose and potentially resolve the issue. Inspect HTML elements. Right-click on your web page, select Inspect or Inspect Element, depending on your browser, and go to the Elements tab in your browser's developer tools. Check if the less than div greater than elements with IDs, EEG_signal, and EEG_spectrum are present in the HTML. Check chart dimensions. Make sure that the less than div greater than elements where you intend to display the charts have a sufficient size defined in your HTML or CSS. You can set a fixed size or use percentage-based sizing. For example, in your HTML, you can add a style attribute to the chart less than div greater than elements. The above code sets a width to 100% of the parent container and a fixed height of 400 pixels. Adjust the dimensions to fit your layout. Check Plotly configuration. In your JavaScript code, ensure that you're correctly configuring the Plotly charts to use the correct less than div greater than elements as their containers. For example, verify that the first argument of Plotly, new plot, matches the ID of the corresponding less than div greater than element. Ensure data availability. Confirm that the data, t, EEG_signal, frequency, EEG_spectrum, is available and properly formatted in the JavaScript code.
Yeah, why didn't it get those two to begin with? So in the HTML, we only have the header and ID, but it should look like this. It should have the size. Let's see. Right. So now we have them larger. Just get an error, but we didn't actually see it. No. Then in the JavaScript, Plotly. So all of that bit is missing. Can you rewrite the whole JavaScript script code without any missing bits, without any placeholders, and assume we're placing it into a separate file?
Certainly, here's a complete JavaScript code for your Plotly charts without any missing parts or placeholders. You can save this code in a separate JavaScript file, such as charts.js, and include it in your HTML file using the less than script greater than tag. You can save this code in a file named charts.js and include it in your HTML file like this. Make sure the less than script greater than tag referencing charts.js is placed at the bottom of your HTML file, just before the closing less than body greater than tag, to ensure that the DOM elements exist when the JavaScript code is executed.
Right, so we're replacing all this in the JavaScript. Let's do that as well. Format document. So that should be fine. You have to speak clearly. We need the bot to understand what I'm saying. The bot. Okay. pretty sure in the future, instead of learning pronunciation, we will learn English just by talking to a robot and see if it gets what we are saying. Then we know that our pronunciation is correct. Like this. Okay. Let's see, we changed the script. And why is this window just not constantly scrolling? Don't get it. And they're actually charging or trying to charge money for it. I did pay them for 1 month. I didn't find that useful because yeah, I was already talking about it before. Let me know if interested. I can turn it into a separate video. And now we need a chart.js. Let's just go into the main folder. And that's its content. Right, so I had it before. This work. Chart.js not found. Really? Do we need to? Yeah, maybe because we're not in development. Need to restart. Chart.js. What's my folder structure should be, and folder and file structure should be?
For a typical Flask web application with a folder structure that includes stat files and templates, the recommended folder structure is as follows. Here's a breakdown of the key folders and files. Your _project_ folder. This is the main folder for your.
Okay, so we should have another folder called static, and the charts JavaScript should be the static folder. Let's try this again. Oh, come on. Still not found. I think because this is not in. No, it is in debug mode. Let's quickly restart this. It's not populated. Oops, F12. Okay, still get this one. Okay.
The error message you're encountering, get http://127.0.0.1:5000 path:/charts.js net. Error underscore aborted 404, not found, indicates that the browser is unable to locate the charts.js JavaScript file at the specified URL. This typically happens when the file is not in the expected location or there's an issue with how it's being referenced in your HTML template.
Okay, so the script in HTML should change to that, and the Flask app. Yeah, that's what we've been struggling yesterday with, so static folder. It's called static. Right. We have a proof. Yeah, as the thing indicates. We're having an issue.
I see you're still encountering the 404, not found, issue with the charts.js file in your...
Come on, no.
The uncaught syntax error, unexpected token, error typically occurs when there is a syntax error in your JavaScript code. In this case, the error is occurring at line 16, character 14 of your charts.js file. Here's how to troubleshoot and fix the issue. Check line 16 in charts.js, open your charts.js file and navigate to line 16, character 14. Examine the code at that location to identify any syntax errors, such as missing braces, semicolons, or other issues. The code you provided appears to be part of the JavaScript section in your charts.js file for creating and updating plotly charts. These lines are responsible for defining the data that will be used to create the EEG signal and spectrum charts. It uses template tags, which suggests that this JavaScript code is embedded within a Flask template. The data being used in these lines is likely coming from the Python code in your Flask application and is being passed to the template using template rendering. Here's a brief explanation of each variable. T. This variable is assigned the value of T.
That's the one we're having trouble with.
If you're encountering issues with the data being passed from Flask to your JavaScript code for creating plotly charts, it's essential to ensure that the data is correctly formatted as JSON and accessible in your template. Here are some troubleshooting steps to ensure that the data is passed correctly. DAT formatting in Flask. In your Flask application, check how you are rendering the template and passing the data to it. Make sure that you are correctly formatting the data as JSON using the to.json filter. For example, Python copy code return render underscore template, index, HTML, T equals T, EEG underscore signal equals EEG underscore signal, frequency equals frequency, EEG underscore spectrum equals EEG underscore spectrum. Ensure that T, EEG underscore signal, frequency, and EEG underscore spectrum are Python variables that contain valid data. Ensure that T, EEG underscore signal, frequency, and EEG underscore spectrum are Python variables that contain valid data. Inspect HTML template. In your HTML template, usually, index, HTML, check that the template tags T, to.json, EEG underscore signal, to.json, frequency, to.json, and EEG underscore spectrum, to.json, are correctly used where the JavaScript code is located. They should be used within a script tag or JavaScript block, and they should be inside the %. Template delimiters if you're using Flask templates. Check variable names. Ensure that the variable names used in your JavaScript code, T, EEG underscore signal, frequency, and EEG underscore spectrum, match the names of the variables passed from Flask, T, EEG underscore signal, frequency, and EEG underscore spectrum. JavaScript errors. If there is a syntax error or other issue in your JavaScript code that prevents it from executing, it can impact the data. Check the JavaScript console in your browser for any errors or issues. Inspect data. Insert debugging statements in your JavaScript code to log or display the received data, T, EEG underscore signal, frequency, and EEG underscore spectrum, in the browser's console to verify that it's correctly received.
Why aren't we just turning the data into JSON using Python instead of JavaScript? Because it seemed to have trouble with JavaScript to create and update plotly charts bit in the JavaScript code.
You're correct that converting data to JSON in Python and passing it to JavaScript can be a more straightforward approach, especially if you're encountering difficulties with JavaScript code for JSON conversion or if you want more control over the data formatting. Converting data to JSON in Python ensures that the data is correctly formatted before it reaches the JavaScript code, reducing the chances of JSON-related issues in the client-side code. Here's how you can convert data to JSON in Python and pass it to JavaScript. In your Flask application, you can use the JSON dumps function from the JSON module to convert your Python data structures into JSON format. Example, Python copy code import JSON. Hash convert Python data to JSON. T_JSON equals JSON, dumps T. EEG_.
If I'm doing that and I'm calling it tJSON, what's going on? Okay, this is where we normally need to do this. We pop the whole script.
Your HTML code appears to be the template for your synthetic signal generator web application.
And just let it run, let it produce what it needs to produce.
Generate synthetic EEG signal. The generate_synthetic_E function generates a synthetic EEG signal using the chirp function from SciPy for different frequency bands, delta, theta, alpha, beta, gamma, and returns the time t in the EEG signal. Update signal and spectrum. The update_signal_spectrum function updates the EEG signal and its spectrum based on the current parameter values. It uses global variables to store and update these values. Flask root and post.
Should have started a new session, ChatGPT session. Just let it do this bit, because I found that really doesn't like when you stop the bot from doing what it wants. Now, instead of creating and updating plotly charts in JavaScript, turning them to JSON, can we use a JSON library and turn the data to JSON using Python?
Yes, you can use Python to create and update the plotly charts on the server side and then send the updated chart data as JSON to your web page. This approach can simplify the client-side JavaScript code because you won't need to create and update the charts directly in JavaScript. Here's a high-level outline of how you can achieve this. Generate and update chart data in Python. In your Flask application, use Python to generate and update the data for the EEG signal and spectrum charts. This means that you'll use Python to create the t, EEG_signal, frequency, and EEG_spectrum variables with the updated data. Send JSON data to the web page. In your Flask root handler, instead of rendering the template with the data as template variables, you can send the JSON data as a response to a specific URL endpoint. Client-side JavaScript. On the web page, you can use client-side JavaScript to make an AJAX request to the URL where the JSON data is served. When the JSON data is received, you can use it to update the plotly charts on the client side. Here's a simplified example of how your Python code might change. In this example, we've created a new root, get_chart_data, that returns the updated chart data as JSON. The JSONify function helps create a JSON response. On your web page, you can use JavaScript to make an AJAX request to get_chart_data, receive the JSON data, and then update the plotly charts based on the received data. This approach separates the data generation and chart rendering on the server side from the client-side chart updating, making your code.
It seems like import JSON is not being used in the code.
You're correct. I apologize for the oversight. In the code I provided in my previous response, the JSON module is imported but not used explicitly in the code snippet. Here's the corrected snippet with the JSON module properly utilized to convert the chart data to JSON format. With this change, the JSON module is now correctly used to convert the chart data to a JSON format, which can be returned as a JSON response to your web page.
Where is the JSON model being used? I can only see JSONify being used.
I apologize for any confusion. In the provided code snippet, the JSONify function from the Flask library is being used to convert Python data to JSON format for the response. The JSONify function implicitly utilizes the JSON module internally. Here's a breakdown of the relevant lines of code. In this line, both the JSONify function and the JSON module are imported. The JSONify function is used to create a JSON response. In this section of the code, a Python dictionary, chart_data, is created to store the chart data. The toList method is used to convert NumPy arrays to Python lists. Here, the JSONify function is called with the chart_data dictionary as an argument, and it returns a JSON response. So, while the JSON module is not used explicitly in this code snippet, it is utilized internally by Flask's JSONify function to handle the conversion of Python data to JSON format for the response.
Okay, I'll take your word for it. Now, so in our Python, a Flask render template request in JSON file. So we do that. In up root get method had a get and post. And what? Get chart data. Python. So I'm confused. Is this a new function? Then we don't need that, do we? How do I change the code?
To properly utilize the JSON module to convert the chart data to JSON format in your Flask application, you need to make the following changes. Import the JSON module. Import the JSON module at the beginning of your Python script. Ensure that the JSON module is imported as shown below. Python copy code import JSON. Modify the get_chart_data root. Inside the get_chart_data root handler, update the code to use the JSON module to convert the chart data to JSON format. Here's the modified code. In this code, we use JSON dumps to convert the chart_data dictionary.
But did I have it already, or don't get it? I didn't have get chart data. We had this index. Can you generate the whole Python code without any missing bits or placeholders?
Certainly, here's the modified Python code for your Flask application without placeholders.
Yeah, that's all the same.
This code includes the entire Flask application for generating and updating synthetic EEG signals and serving the data as JSON when accessed via the get_chart_data endpoint. It removes any placeholders and provides a complete working example.
Right. So still in debugging mode. To list, we're now using. So that looks legit. Let's It's already 100 lines of code. Why is it not populated? The JSON file. Can you also generate the JSON file with all the updated changes and without any missing bits or placeholders?
I understand that you want to generate the complete JSON data for your Flask application without any missing bits or placeholders. Here's the JSON data structure that corresponds to the Python code. This JSON data includes placeholders for the time, t, EEG signal, EEG_signal, frequency, and EEG spectrum, EEG_spectrum, arrays. It also includes default values for the window size, amplitude, and bandwidth parameters. You can use this JSON data as a template for initial.
Sorry, I meant JavaScript, not JSON.
Certainly, here's the JavaScript code for updating the plotly charts without any placeholders.
Right, so those are the variables that should be taken from the application. Just checking that there's no missing bits. Why did it stop? Do I have to pay? Hopefully not.
This JavaScript code initializes default values, fetches updated chart data from the server using the get_chart_data endpoint, and updates the EEG signal and spectrum charts accordingly. The code also includes an event listener to trigger chart updates when the form is submitted. Please ensure that this JavaScript code is placed in a separate file named charts.js and is included in your HTML template using less than script src equals /static/charts.js greater than less than script greater than.
Right, so now we are in business. Obviously the spectrum looks super weird, but we can fix that. Does it look like EEG? I don't know. Don't have an icon, we'll sort that later. It's not scaling properly on the screen. Right, it is now. Only on refresh. So we have 10 seconds. Is this refreshing anything? No. I was expecting it to. Yeah, that's. Yes, we have a thing running on the live server, would be on port 5500, and that doesn't actually load. I don't know if it's yeah. Yeah, I want to be able to run it from here, but it doesn't. Doesn't run. We'll sort it later. That's what we were fighting with yesterday. But back to the app. So that's working now. But there, if you peculiar things. One is the frequency domain going from zero, going from negative something to positive something. Can we change that to go to be logarithmic scale? Obviously that will be only positive. And also the charts are not updated when changing values in the application. How do we fix that?
I understand your concerns. It seems you have two specific issues. Frequency domain scaling. The frequency domain currently spans from negative values to positive values. You'd like to change it to a logarithmic scale for better visualization. Charts not updating. The charts are not updating when changing values in the application. Let's address these issues one by one. 1. Frequency domain scaling. To change the frequency domain to a logarithmic scale, you can modify the x-axis of the EEG_spectrum chart. Specifically, you can set the x-axis type to log in the chart layout. Here's how to do it. This modification will change the x-axis of the spectrum chart to a logarithmic scale. 2. Charts not updating. The issue of charts not updating when changing values in the application might be related to how you trigger chart updates. Make sure that the update charts function is correctly called when the form is submitted. Here's a revised version of the event listener for form submission. Ensure that you have correctly placed this event listener in your JavaScript code. If you still encounter issues with the charts not updating, please double-check the code to ensure that there are no JavaScript errors or console messages that might provide more information about the problem. Additionally, you may need to inspect the network requests to ensure that the data is being fetched and updated correctly from the server.
Okay, so that one we already have it in the same form, I think. Yeah, that's just the same. Do we already have this layout? Title spectrum, frequency type. So replace x-axis with that. We have to refresh. This is still, why does it has 10? Is that legit? Don't think so. It does look a lot like EEG. Something more repetitive happening over there. Alright, we have update button that didn't work. No, icon is okay. Is it updating anything? Doesn't look like. There's no error. That's not actually updating. Yeah, I won't be able to change them quickly, so I would like sliders. The spectrum, why is it jumpy like that? And the bandwidth, yeah, I want to draw them as separate things. window size. 5 is default, and with those you can control this spectrum. So you can set higher or lower delta band. Once you set the amplitude, you can change the width of it. So okay, so what do we need to do is change those controls. First of all, this update button doesn't seem to work. There's no error messages or anything. Get chat data. It's 50. It's updating, okay. Close that. Update charts. Fetch get charge chart data. Bum, bum, bum. Take a quick break. Pop the just check. Close that. No, instead of logarithmic, probably want to go back. Okay, a couple of things. First of all, we would like to change the frequency x-axis scale back to linear and have it from about 0 to 50 Hertz. All the controllers should be sliders instead of text boxes.
Sure, let's make the requested changes. Frequency x-axis scale and range. We will change the frequency x-axis scale back to linear and set the range from 0 to 50 Hz. Controllers as sliders. We will replace the text boxes with slider controls for the amplitude and bandwidth values of each frequency band. Here's the modified JavaScript code for these changes. With these changes, the frequency x-axis will be linear, ranging from 0 to 50 Hz, and the amplitude and bandwidth controllers will be implemented as slider controls.
To update anything else, I assume. These are not sliders. I'm getting 200, which is correct response, but nothing is changing. Amplitude. The amplitude doesn't look right. I don't see any sliders. It's still the old text boxes.
I apologize for the oversight. To implement sliders for amplitude and bandwidth controls, you'll need to use HTML less than input greater than elements with the type attribute set to range to create slider controls. Here's a modified HTML and JavaScript code. You will need to repeat this pattern for each amplitude and bandwidth control, changing the name, it, and default values accordingly. JavaScript for sliders. Ensure that you replace the existing HTML and JavaScript code with the code above, which includes the slider elements and initializes their default values. This will enable slider controls for amplitude and bandwidth adjustments.
Okay, why not generate the whole code? Could you generate the whole? Can we generate the whole code with the recent changes?
Certainly, here's the updated HTML, JavaScript, and Python code with the recent changes, including the use of slider controls for amplitude and bandwidth. HTML, index, HTML. JavaScript, charts, JS.
Uh, Please generate the whole code without any missing bits or any placeholders.
Certainly, here's a complete code for your synthetic EEG signal generator with all the recent changes. HTML, template/index.html. JavaScript, static/charts.js.
Yeah, this is where it starts refusing generating the whole code. This one seems to be complete.
Python, app.py. With these changes, you'll have the complete code for your synthetic EEG signal generator with sliders for amplitude and bandwidth controls, a linear scale for the frequency axis, and the ability to update charts when changing values in the application.
I am pretty sure that's the same. Not sure what changed here. It's the slider. Be the Stop it for a sec. Anyway, it's not updating. Yeah, let's start a new chat.
The HTML code you provided appears to be a basic web page for a synthetic EEG signal generator. Here's a breakdown of the components and their functionality. The entire content is wrapped within the less than HTML greater than element. The less than head greater than section contains metadata and references to external resources. The less than body greater than section contains the visible content of the web page. Less than meta charset equals UTF-8 greater than specifies the character encoding of the document as UTF-8. Less than meta name equals viewport content equals width equals device width initial scale equals. The provided Python code is a Flask web application that generates a synthetic EEG electroencephalogram signal and its spectrum based on user-defined parameters. Below is a breakdown of the code's functionality. Imports. The code imports necessary libraries and modules, including Flask, NumPy, SciPy, and JSON. Flask app initialization. It initializes a Flask web application named app and specifies a folder named static to serve static files like JavaScript and CSS. Default parameters. Default parameters for the EEG signal generation are defined, including the default window size, amplitude values for different EEG bands, delta, theta, alpha, beta, gamma, and bandwidth values for these bands. Generate _synthetic _EEG. This function generates a synthetic EEG signal by using the chirp function from SciPy for different frequency bands, delta, theta, alpha, beta, gamma. The generated EEG signal is a combination of these frequency components. Index route. This route handles both get and post requests. When the user accesses a web page or submits the form, it updates the global parameters, window _size, amplitude, bandwidth based on user input. It then calls update _signal _spectrum to generate the EEG signal and spectrum and renders the index HTML template with these data for display. Update _signal _spectrum. This function updates the synthetic EEG signal and its spectrum based on the current parameter values, window size, amplitude, and bandwidth. It calls generate _synthetic _EEG and computes the EEG spectrum using the fast Fourier transform FFT. Main block. The code runs the Flask app if a script is executed directly, not imported as a module, and it runs in debug mode. Debug equals true for development. Get _chart _ The JavaScript code you provided is used to enhance the functionality of the web page generated by your Flask application. It primarily handles the following tasks. Setting default values on page load. When the DOM content is fully loaded, using DOM content loaded event, the script sets default values for various input fields on the page, such as the window _size and the sliders for amplitude and bandwidth for different EEG bands, delta, theta, alpha, beta, gamma. Updating plotly charts. The script defines a function called update charts that fetches updated chart data from the server when called. It sends a GET request to the get _chart _data endpoint of your Flask application to obtain data for the EEG signal and its spectrum. EEG signal chart. It updates the EEG signal chart with the synthetic EEG signal data obtained from the server. This chart displays the EEG signal over time. Chart configuration and rendering. The script uses plotly to configure and render two charts. Initial chart update. The script initiates the initial chart update by calling the update charts function when the page loads. This ensures that the charts are displayed with the default values on page load. EEG spectrum. If nothing happens when you update the values and click the Update EEG button, it could be due to various reasons. Here are some steps you can take to check and troubleshoot the issue. Browser console. Open your browser's developer tools, usually by pressing F12 or right-clicking on the page and selecting Inspect or Inspect Element, and go to the Console tab. This console often displays JavaScript errors. Check if there are any error messages when you click the button. Network tab. In your browser's developer tools, go to the Network tab. When you click the Update EEG button, it should show network requests being made to your server. Check if there's a request to get_chart_data and see if it returns the expected data. Check Flask logs. In your Flask application, you can add print statements or use a logging library to log messages. These messages can help you debug your application. For example, you can add print statements in the update_signal_spectrum function to ensure it's being called. Browser cache. Sometimes browsers may cache JavaScript files. Ensure that you've cleared your browser cache or use a private incognito window to rule out any caching issues. Server logs. Check your server logs for any errors or issues. The Flask server may provide information about incoming requests and potential errors. Verify URL. Ensure that the JavaScript code is correctly referencing the get_chart_data endpoint in the fetch function. It should match the URL route defined in your Flask app. The fact that you're getting a 200 OK status code when you request http://127.0.0.1:5000/get_chart_data is a positive sign. It means that the GET request to fetch chart data from your Flask server is working correctly and the server is responding as expected. Since the server is responding with a 200 OK status code, it implies that the issue might be related to the JavaScript code or the way the chart data is being handled on the client side. Here are some steps you can take to further diagnose the issue. Console output. In your JavaScript code, add console.log statements to various parts of the update charts function to check if it's being called and to display the data being fetched. For example, this will help you see if the function is being executed and if the data is being retrieved successfully. Chart initialization. Ensure that the HTML page contains the less than div greater than elements with the IDs_signal and EEG_spectrum, which are targeted for chart rendering. Make sure there are no typos or errors in these IDs.
So we've been doing this console logging to troubleshoot here. It's not called data, is it?
The error message you've received, uncaught reference error, data is not defined, indicates that there's an issue with the data variable being referenced in your JavaScript code. It seems that the data variable is not defined or accessible at the point where it's being used. To resolve this issue, make sure that the data variable is properly defined and accessible within the update charts function. It should be defined after the successful response from the server, which is obtained through the fetch API. Here's how you can modify your update charts function to handle the response correctly. In this updated code, the data variable is defined within the scope of the then block after the successful response from the server. Additionally, I added a catch block to handle any errors that might occur during the fetch request. This should resolve the data is not defined error and ensure that the fetch data is correctly used to update the charts.
I knew that. Okay. It's like it's always easy to updating charts. Well, I didn't know about the other line. Why? Fetch. just to place this function. Dating chats. It just takes forever, is it? So if I turn this to updating chats, it's not actually so it seemed to update the chats without any errors. However, there are no changes to the synthetic EEG and its spectrum charts.
If you've resolved that data is not defined, error and the update charts function is running without errors, but the charts aren't updating with the new synthetic geek data, there might be an issue with the chart rendering or the plotly configuration. Here are some steps to troubleshoot this issue. Check chart containers. Verify that the less than div greater than elements with the EEG underscore signal and EEG underscore spectrum exist in your HTML code and that these IDs match the IDs used in your JavaScript code for chart rendering. Verify data. Ensure that the data retrieved from the server, EEG underscore signal, frequency, EEG underscore spectrum, is valid and contains the expected values. You can add console.log statements to display these variables in the console to verify their contents. Chart configuration. Double-check the configuration options for your plotly charts. Make sure that the X and Y values are correctly assigned and that the chart layout settings are appropriate. Chart initialization. Ensure that the charts are correctly initialized before calling plotly, React. You can initialize the charts using plotly, new plot the first time and then use plotly, React for subsequent updates. Here's an example of how to initialize the charts. Then, in your update charts function, use plotly, React as you have been doing. Check for JavaScript errors. Inspect the browser's console for any JavaScript errors that might be occurring during chart rendering or any other part of your code. Plotly version. Ensure that you are using a compatible version of the plotly library. Sometimes, compatibility issues can arise if you are using an outdated or incompatible version. Debugging. Use the browser's debugging tools to step through your JavaScript code and see if there are any unexpected behaviors or issues during the chart rendering process.
We initializing the charts must do. Oh no, we don't. I know we do. There's no new plot. Why don't I have any of that? Is this another function? No. Can we pop that in?
Your JavaScript code appears to be well structured and should work for updating plotly charts when the form is submitted. However, if the charts are still not updating as expected, let's go through a checklist of potential issues and debugging steps. Browser console. Open your browser's developer tools, usually by pressing F12 or right-clicking on the page and selecting Inspect or Inspect Element, and go to the Console tab. This is where JavaScript errors and logs will appear. Check for any error messages or log messages related to your JavaScript code. HTML structure. Confirm that the less than div greater than elements with the IDs.
I didn't have this code before. It's almost like assuming. I already had it. I have a Plotly React, but there's no new plot. So that's probably now. How do I where does the chat initialization JavaScript code goes to? Yeah, I don't know exactly how to implement it. Sorry for that.
The chart initialization JavaScript code should be placed in the same JavaScript file or script as the rest of your code, typically within the DOM content loaded event listener function or in a separate function that is called when the page loads. Here's where you can place the chart initialization code. Within the DOM content loaded event listener, this is a common place to put initialization code as it ensures that the code runs when the page is fully loaded. You can add the chart initialization code right after setting default values and before defining the update charts function. Here's an example. In a separate function, you can also place the chart initialization code in a separate function and call that function from within the DOM content loaded event listener. This can help keep your code organized and easier to maintain. Here's an example of placing the chart initialization code in a separate function. Either of these approaches will work, but the first approach, placing the initialization code within the DOM content loaded event listener, is simpler and ensures that the charts are initialized as soon as the page is ready.
What? You have 100 lines JavaScript code. Can you generate the whole JavaScript code without any missing bits or placeholders and include the initialization of the charts?
Certainly, here's a complete JavaScript script, including the chart initialization code, without any placeholders.
I don't know why it didn't just include it to begin with. I have no idea. Update charts.
This
Still
script includes
logging.
the initialization of the default values for the form, the initialization of the EEG signal and EEG spectrum charts using Plotly, and the update charts function to fetch and update chart data when the form is submitted.
Text, it's pretty quick to begin with. It's still not not changing. How about window size? The charts don't seem to update. The charts for synthetic EEG and spectrum do not seem to update when amplitudes, bandwidths, or window size is changed.
If the charts for the synthetic EEG and spectrum are not updating when the amplitude or window sizes change, there might be an issue with how the form submission and chart updating are coordinated. Here are some steps to troubleshoot and ensure that the charts update correctly. Check form submission. First, ensure that the form submission is triggered correctly when you change the amplitude or window size and click the Update EEG button. Add a console.log statement within the form submission event listener to verify that it's being triggered. JavaScript copy code, event listener for form submission. Document, query selector, form, add event listener, submit, function, event. Event, prevent default, prevent form submission. Console.log, form submitted, add this line to check form submission. Fetch updated chart data from the server. Update charts. Closing curly bracket, closing parenthesis, semicolon. When you change the values and click Update EEG, you should see Form Submit in the console. When you change the values and click Update EEG, you should see Form Submit in the console. Check form fields. Ensure that the form field IDs, window underscore size, amplitude underscore delta, etc., match the IDs used in your JavaScript code when you access their values. Double check that there are no typos or mismatches. Check server response. Verify that when you submit the form, the server is receiving the updated values correctly. You can add debug statements in your Flask route to print the received values and check if they match what you expect. Check chart update logic. Inspect the update charts function to make sure it's correctly fetching the updated data from the server and updating the charts. You can add console.log statements at various points within the function to see if it's being executed as expected and if the data is correctly retrieved. By adding these console.log statements, you can see if the data is being received and if the chart update logic is working as expected. Inspect network requests. In your browser's developer tools, go to the Network tab and observe the network requests when you submit the form. Check if the get request to get underscore chart underscore data is being made after form submission and if it's returning updated data. Check for JavaScript errors. Look for any JavaScript errors in the browser's console that might be preventing the form submission or chart update logic from running correctly. By systematically checking these points and using console.
Yeah, we need to check this extra. So in update chart, just place more logs. So we have console log updating charts, just text in the browser, fetch, then response JSON, data, heading. Wanna place that. Never. No. Yes. Catch error at the end. We already have that. Let's see. So we have these values: EEG signal, frequency, time. Okay. So we have the values going through. So if we change the amplitude of theta from 1 to 100, T value should be the same. EEG signal. Okay. 5 EEG signal. So obviously it's exactly the same. And it should not be. How do I check that?
To ensure that the form field IDs match the IDs used in your JavaScript code and that there are no typos or mismatches, follow these steps. HTML form IDs. Open your HTML file, where the form is defined, and confirm that the ID attributes for your form fields match the IDs used in your JavaScript code. Here's a snippet of your HTML form. Ensure that the id attributes for each input element match exactly with what you are using in your JavaScript code. In this case, id equals window underscore size should correspond to document get element by id window underscore size in your JavaScript code. JavaScript code. Double check your JavaScript code, especially within the update charts function, where you access the form field values. Ensure that the IDs are correctly referenced without any typos. Here's an example from your code. Ensure that the keys used to access the form fields, window underscore size, amplitude underscore delta, etc., exactly match the id attributes of the corresponding form elements in your HTML.
Let's check those just default values, are they? Because that's the ones I'm trying to change. Get element by ID. Is this in JavaScript? So I don't have that line. Request from what? Update the charts function. Fetch update chart data from the server. So there's update charts and get charts data. Okay, there's some sort of get chart data. I don't have these lines. Let's see if I... Okay. Let's just pop this charts JS so it knows which one is which, up, y. Oh, that's kind of obvious. Let's pop in the do I have requests from anywhere? JSON file is not being used. JSON file, JSON request. So this is not in JavaScript, this is in Python. Windows size. It's working okay to begin with. Did make a mistake, this should say Python. Put this in.
Your app.py code appears to be correct and complete for a Flask web application that generates a synthetic EEG signal and updates it based on user input. It also serves as a JSON API for fetching chart data. Here's a summary of what your code does.
That's okay, I know what it should do. and it doesn't do some of it.
Your charts. JS code appears to be correctly set up to initialize and update the EEG signal and EEG spectrum charts using Plotly. It also includes default values for the form fields and handles form submissions to update the charts dynamically. Here's a summary of what this code does.
Okay, it does not update dynamically. It does not seem to update dynamically. For example, when changing amplitude theta from 1 to 100, the charts, synthetic EEG and spectrum remain the same.
If the synthetic EEG and spectral charts are not updating dynamically when you change the amplitude values, it's possible that there is an issue with the JavaScript code or the interaction between the client-side, JavaScript, and server-side, Flask, components. Here are some steps to troubleshoot and resolve the issue. Check the Network tab, open your browser's developer tools and go to the Network tab. When you change the amplitude values and click Update EEG, check if there is a network request, e.g., to get_chart_data being made and if the response contains the updated data. Ensure that the server is receiving the new amplitude values and sending back the correct data. Server-side code. Review your Flask server-side code in app.py that handles the form submission route. Ensure that the updated amplitude values are correctly applied to the EEG signal generation. You can add print statements or log messages to verify that the new values are being processed. Console logs. In your JavaScript code, charts.js, add additional console.log statements to help debug. For example, you can log the values of amplitude before and after the form submission to make sure they are correctly updated. Check the console logs to ensure that the updated amplitude values are correct.
Yeah, I do want to do this because I'm pretty sure it's actually not working correctly. This will be at the bottom. Query selector, prevent default console form submitted, console log. Yes. Move it up a notch. So only monitoring delta and theta. Let's see if it actually does something. Delta. So say if I change it to 10, this number should change to 10. It does change to 10. Okay, so that's working correct. Assume theta, say 100. It's working okay. But the received data, EEG signal, haven't changed. Those numbers are exactly the same. No warnings. So this one is not working.
If the charts are not updating correctly, it's important to ensure that the server is sending the correct data in response to the get_chart_data request, including the updated amplitude values. Here are the steps to check the server response. Inside this route, make sure that you are correctly updating the amplitude values in the response data. These values should reflect the changes made in the form. Verify that the chart_data dictionary includes the updated amplitude values before converting it to JSON. It should look something like this. Server-side code, app.py, get_chart_data endpoint. In your Flask app.py file, look for the get_chart_data route, which handles the chart data request. Inside this route, make sure that you are correctly updating the amplitude values in the response data. These values should reflect the changes made in the form. Verify that the chart_data dictionary includes the updated amplitude values before converting it to JSON. It should look something like this. Python copy code chart_data equals t to list. EEG_signal, EEG_signal, to list. Frequency.
Okay, so there's a problem. The chart data only doesn't have amplitude. Oh, come on. Why didn't it come up with an error?
The code you provided for creating the chart_data dictionary in your Flask app.py file appears to be correctly sending the EEG signal, spectrum, time values, and frequency data to the client. However, it does not include the amplitude values. To include the updated amplitude values in the chart_data dictionary, you should modify it to include the amplitude dictionary as follows. With this modification, the chart_data dictionary will contain the amplitude values along with the other data, and it will be sent to the client when the get_chart_data endpoint is requested.
Yeah, why didn't you do it to begin with? Still not updating.
The code you provided for your Flask application, app.py, looks correct, including the addition of the amplitude values to the chart_data dictionary and the get_chart_data route. This should send the updated amplitude values to the client when the chart data is requested. Now, let's focus on the client-side JavaScript code, charts.js. Ensure that it correctly retrieves and uses the updated amplitude values from the server's response to update the charts dynamically. Here's your modified charts.js. Make sure that you've updated your client-side code as shown above. This code retrieves and uses the amplitude values from the server's response to update the charts dynamically when the form is submitted.
Yeah, obviously that's not working. Might take it offline. Some sort of silly mistake. Hopefully, yeah. Hopefully we'll get quicker at making these things. So eventually it will replace this one here. And you will be able to check it out yourself. But now it's only that one works. I don't know why it takes for it some time to update the chats. We'll fix it later. See ya. Bye.